This is a beginner video about learning ESP-IDF framework to work with the ESP32. To be specific, we're going to create a simple Hello World and LED Blink app. Then I will use the code as a demonstration to explain some key concepts. Please note that this video isn't a guide on setting up the environment. But if you need help with that, I have included links in the description on how to install the ESP-IDF toolchain and then configure it with the ESP-IDF extension for Visual Studio Code. Anyways, once you have completed the setting up step, let's get started. We're going to click on the ESP-IDF icon on the left and create a new project. You can choose whichever template you want here, but I will start with basic one, that is Blink, and then modify it from the beginning. I will change the C makelist file here, since previously I encountered a trouble where VSCode couldn't find the GPIO header file. Before we code, I want to introduce you to FreeRTOS, which is the real-time operating system designed for microcontroller and microprocessor that the ESP-IDF toolchain use. Note that there are differences between the vanilla FreeRTOS I'm showing you the website of and the FreeRTOS implementation that the ESP-IDF tool used. The reason why I'm talking about this is because when you build an application on your MCU, you're going to have many independent tasks and subroutines. Note that ESP32 has 2 cores and thus can run 2 tasks simultaneously, which is not the case for single-core MCU. FreeRTOS has a scheduler to manage the execution of many tasks based on their priority and other factors. Just keep in mind that the higher the priority, the more FreeRTOS will try to execute that task first by preempting lower priority tasks. We print the string Hello World to the monitor. The VTask delay is like the common delay used in Arduino. Note that you'll use the duration in milliseconds divided by this constant to convert it to the tick rate that ESP-IDF use. Here, I'm delaying every second. We'll create a task for our function with xtaskCreate. The first argument is the name of the function we're going to call back, then its name, followed by the stack size, which is the amount of memory we allocate for this task. The fourth argument is the parameter to be used with our callback function. We're setting null since we don't pass anything. The fifth argument is the priority of the task, with 10 being the highest. The final argument is the handle, which is used to reference the created task. Our task handler will be null as it doesn't do anything. Once we're done, we can run it by using the commands provided by ESP-IDF in the command palette of VSCode. Build the program, change the port to the USB port connected with ESP32, then flash it using UAR protocol. There is also another version of this function, which is xtask pinned to core, which has another argument that indicates the core that will be executing this task. This means you can set 2 tasks to 2 different cores and run them simultaneously. The 2 cores of the ESP are denoted as 0 and 1. We'll revisit this task later, but let's talk about GPIO for a bit. An MCU, or a microcontroller unit, consists of CPU, memory, and peripherals that support a wide variety of functions. One of the most basic peripherals is GPIO, or General Purpose Input or Output. They are called general purpose because they can work as both the input and output ports depending on our needs. For example, one pin can be used as input for data coming from an external module, and then be changed to output to give a controlling signal to that same module. GPIO pins use signal levels, low and high voltage. Look for the pin map of the ESP32 that you have to find out which GPIO pin you can use. Note that there can be restrictions as shown. Here are some of the common functions related to GPIO that I'll introduce. You should pause the video and read through it. You might feel a little bit familiar if you have already used an Arduino before. There is an important aspect that I included, but this video doesn't feature yet, but you should check it out. That is the interrupt mechanics, which will call a handler when the value of a pin is detected to have changed. This is also a much more optimal solution than continuously reading input value from a pin, which has higher latency and may lead to inaccurate timing. Select our pin, which will connect to the LED, configure it to be the output pin. Then we will write high then low to a pin with a 1-second interval in a while loop that is always true. Flash the code and you can see the LED blinking. I assume you know how to wire an LED, but don't forget to use a resistor. All right, now we can combine these two. Let's use some task management functions, including vtask suspend, to temporarily stop a task, vtask resume to resume the paused task, and vtask delete for deleting a task. The argument for all of them is the handle of the task. If we pass null directly, then the function will apply for the task that was calling it. In this case, after flashing for 10 seconds, our task is paused till the 14th second and is deleted permanently at the 20th second. Finally, we run them simultaneously with the blink task running on core 0 and the hello world task on core 1. Let's see the output. You can ignore the undefined characters printed to the serial monitor. It's working as expected, and the LED will keep blinking even after our Hello World task ended. And that's also the end of this video. If you still want to learn more about ESP-IDF, check the resources in the description. Keep in mind that I might upload more videos in the future on this topic. Hope my videos can be of help, and if so, don't forget to drop a like and subscribe.